Arc fault circuit interrupters, or AFCIs, are designed to protect against fires caused by electrical arcing. However, some claims about their capabilities can be misleading. Let's address two specific points. Firstly, high-resistance series faults. The claim is that AFCIs can mitigate high-resistance series faults by responding to the resulting parallel arc or ground fault. This is somewhat misleading. While AFCIs are indeed effective at detecting parallel arcs and ground faults, their ability to reliably detect high-resistance series faults is limited. A high-resistance series fault occurs when there's a loose connection in a circuit. This creates resistance leading to heat buildup. If this heat becomes excessive, it can ignite nearby materials and cause a fire. The problem is that AFCIs are primarily designed to detect arcing faults, not the heat generated by a high-resistance connection. The current flow in a high-resistance series fault might not be high enough to trigger the AFCI's arc detection circuitry. The AFCI might only trip if the insulation around the wiring fails due to the heat, leading to a parallel arc or ground fault. But ideally, you want to prevent the fire hazard before it gets to that stage. Secondly, series arcs. The claim is that series arcs are common and unlikely to cause fires. It is true that series arcs occur frequently in homes. A common example is when you turn a light switch on or off. A tiny arc can occur as the contacts make or break. However, the statement that series arcs are unlikely to cause fires is a simplification that can be dangerous. While many series arcs are indeed harmless, they can still pose a fire hazard under certain circumstances. A series arc is essentially a spark in a broken or damaged wire. These sparks can generate heat, and if they occur near flammable materials like dust, wood shavings, or insulation, they can ignite a fire. AFCIs are designed to detect these series arcs. They look for specific patterns in the current waveform that indicate arcing. When an AFCI detects a series arc, it trips the circuit, cutting off the power and preventing a fire from starting. The fact that series arcs occur frequently doesn't mean they're always safe. It simply means that the risk is always present. That's why AFCIs are so important. They provide an extra layer of protection against a potential fire hazard that might otherwise go unnoticed. Now let's delve a bit deeper into the technical aspects of AFCIs and how they work. AFCIs are designed to protect against fires resulting from arc faults. An arc fault is an unintentional electrical discharge between two or more conductors. These arcs generate heat, which can ignite surrounding materials. There are two main types of arc faults: series arc faults and parallel arc faults. As we discussed, a series arc fault occurs when there is a break in the single conductor. This can happen due to damaged wiring, loose connections, or corroded contacts. The current flows through the arc, which generates heat and can ignite nearby combustibles. A parallel arc fault, also known as a line-to-line or line-to-ground fault, occurs when there is an arc between two conductors or between a conductor and ground. This type of fault typically involves a higher current than a series arc fault and can be more dangerous. AFCIs use sophisticated electronics to detect the unique characteristics of arc faults. They analyze the current waveform for patterns that indicate arcing, such as sudden changes in current, high-frequency noise, and irregular waveforms. When an AFCI detects an arc fault, it quickly trips the circuit, interrupting the flow of electricity and preventing a fire. AFCIs are designed to be more sensitive to arc faults than traditional circuit breakers. Traditional circuit breakers are primarily designed to protect against overloads and short circuits, which involve high currents. Arc faults, on the other hand, can occur at relatively low currents, making them difficult for traditional circuit breakers to detect. AFCIs are required by the National Electrical Code, or NEC, in many areas of the home, including bedrooms, living rooms, and hallways. The specific requirements vary depending on the addition of the NEC and local amendments. It's important to check your local electrical codes to ensure that you are complying with the latest requirements. When selecting an AFCI, there are a few factors to consider. Firstly, the type of AFCI. There are two main types of AFCIs: branch/feeder AFCIs and combination AFCIs. Branch/feeder AFCIs protect the entire branch circuit, while combination AFCIs provide both branch/feeder and outlet circuit protection. Combination AFCIs are generally recommended as they offer the most comprehensive protection. Secondly, the amperage rating. The AFCI must have the same amperage rating as the circuit it is protecting. For example, a 15 amp circuit requires a 15 amp AFCI. Thirdly, the voltage rating. The AFCI must have the same voltage rating as the circuit it is protecting. In most homes, this will be 120 volts for lighting and receptacle circuits. Fourthly, the compatibility. Make sure the AFCI is compatible with your existing electrical panel. Some AFCIs are designed to work with specific brands of panels. When installing an AFCI, it's important to follow the manufacturer's instructions carefully. Firstly, turn off the power to the circuit at the main panel. Secondly, remove the existing circuit breaker from the panel. Thirdly, connect the AFCI to the circuit wiring, following the wiring diagram provided by the manufacturer. Fourthly, install the AFCI in the panel and secure it in place. Fifthly, turn the power back onto the circuit and test the AFCI to make sure it is working properly. AFCIs require periodic testing to ensure that they are functioning correctly. The manufacturer's instructions will specify the recommended testing frequency. To test an AFCI, simply press the test button on the device. The AFCI should trip, interrupting the flow of electricity to the circuit. If the AFCI does not trip, it may be defective and should be replaced. While AFCIs provide valuable protection against arc faults, it's important to remember that they are not a substitute for proper electrical wiring and maintenance. Regular inspections of your electrical system can help identify potential problems before they become hazards. Look for signs of damaged wiring, loose connections, and corroded contacts. If you notice any of these problems, have them repaired by a qualified electrician. In addition to AFCIs, there are other safety devices that can help protect your home from electrical fires. Ground fault circuit interrupters, or GFCIs, protect against electrical shock by detecting ground faults. GFCIs are required in areas where water is present, such as bathrooms, kitchens, and outdoor receptacles. Surge protectors protect against voltage spikes that can damage electronic equipment. Surge protectors are recommended for computers, televisions, and other sensitive electronics. Smoke detectors provide early warning of a fire, giving you time to escape and call for help. Smoke detectors should be installed on every level of your home and tested regularly. Carbon monoxide detectors protect against carbon monoxide poisoning, a silent and deadly killer. Carbon monoxide detectors should be installed near sleeping areas and tested regularly. The electrical safety is an important responsibility for every homeowner. By understanding the risks and taking appropriate precautions, you can help protect your family and your home from electrical fires and other hazards. Remember to always consult with a qualified electrician for any electrical work or repairs. They have the knowledge and experience to ensure that the work is done safely and correctly. Let's consider some common misconceptions about AFCIs. One misconception is that AFCIs are too sensitive and trip too often. While it is true that AFCIs can sometimes trip due to nuisance tripping, this is often due to underlying electrical problems such as loose connections or damaged wiring. In these cases, the AFCI is actually doing its job by detecting a potential hazard. Another misconception is that AFCIs are only needed in new homes. While AFCIs are required in new construction in many areas, they can also provide valuable protection in older homes. In fact, older homes may be at greater risk of electrical fires due to aging wiring and outdated electrical systems. Another misconception is that AFCIs are a waste of money. While AFCIs do cost more than traditional circuit breakers, the added protection they provide is well worth the investment. Electrical fires can cause significant damage, injury, and even death. AFCIs can help prevent these tragedies. Now, let's discuss some best practices for electrical safety in your home. Firstly, never overload circuits. Overloading a circuit can cause the wiring to overheat and potentially start a fire. Use a circuit analyzer to determine the load on each circuit and avoid plugging too many devices into a single outlet or circuit. Secondly, use extension cords safely. Extension cords should only be used temporarily and should never be used as a permanent wiring solution. Make sure the extension cord is rated for the intended use and that it is not damaged. Thirdly, inspect electrical cords and plugs regularly. Look for signs of damage, such as frayed wires, cracked insulation, or loose connections. Replace any damaged cords or plugs immediately. Fourthly, keep electrical appliances away from water. Water can conduct electricity and create a shock hazard. Never use electrical appliances near sinks, bathtubs, or swimming pools. Fifthly, have your electrical system inspected regularly by a qualified electrician. A qualified electrician can identify potential problems and make recommendations for improvements. Sixthly, install tamper-resistant receptacles, or TRRs, in your home, especially if you have young children. TRR have internal shutters that prevent children from inserting objects into the outlets. Seventhly, use light bulbs with the correct wattage. Using a light bulb with a higher wattage than the fixture is designed for can cause the fixture to overheat and potentially start a fire. Eighthly, be careful when working with electricity. Always turn off the power to the circuit before working on any electrical wiring or appliances. If you are not comfortable working with electricity, hire a qualified electrician. In conclusion, AFCIs are an important safety device that can help protect your home from electrical fires. While they are not a substitute for proper electrical wiring and maintenance, they provide an extra layer of protection against arc faults. By understanding how AFCIs work and following best practices for electrical safety, you can help protect your family and your home from electrical hazards. Remember that electrical codes are constantly evolving to improve safety. Stay informed about the latest requirements and consult with a qualified electrician to ensure that your home's electrical system is up to code. Regular maintenance and upgrades, including the installation of AFCIs and other safety devices, can significantly reduce the risk of electrical fires and ensure the safety of your home and family. The information presented here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or repairs.